welcome to the APsolute Recap Biology Edition. I'm your host, Melanie Kingett, and I'll be your guide to scoring a 5. Here at the APsolute Recap, we aim to maximize your understanding and minimize your need for memorization. Each episode will review content, skills, and test-taking tips to help you succeed in May. Your recap starts now. Hi, and welcome to the APsolute Recap Biology Edition. Today's episode will recap population ecology. Let's zoom out. We're in Unit 8, Ecology, Topic 8.3 and 8.4. Our big idea is systems interactions. Population ecology is the study of factors that affect a population and how and why a population changes over time. The most common areas of investigation are the study of population growth, regulation, and dynamics. Buckle up, there's math ahead. Let's zoom in. Math? I thought this was science. The AP Biology equations and formula sheet is allowed as a reference during the test. Make sure you have one handy to use throughout the school year. Keep it in your binder, or for bonus points, 3-hole punch and laminate. So all you need to do is grab your numbers, plug them in, and get your answers. But we know that the interpretation and application of these numbers is where understanding comes in. Oh, and there's graphing too. Deep breath. We are here to help you maximize the understanding and minimize the need for memorization. By definition, a population is a group of organisms of the same species in the same geographic area. These individual organisms interact with one another and with the environment in very complex ways. But it usually boils down to one thing. Everybody needs to obtain and use energy and matter. Economist and Reverend Thomas Malthus wrote an essay in 1798 stating that population growth increases at a faster rate than the food supply. When population sizes are low, there is more food to go around, less competition, less death, and a bit of a utopian existence.
Hooray!
But increase the population beyond food supply, and the competition begins. Not everyone is going to be successful. Malthus was speaking specifically about the human population in his essay, but the basic theory can apply in a broader context. And it did influence Charles Darwin when formulating his own theories on competition and natural selection. Population growth dynamics depend on a number of factors. How do we figure out if it's growing or shrinking over time? Over time. This is a rate calculation, an event occurring over time. The population growth equation is very simple and can likely be solved in your head for most problems. Capital N is always going to represent population size in all of our equations in this episode. The change in population, dn, over time, dt, is equal to the birth rate, capital B, minus the death rate, capital D. Births minus deaths. So if you have more births than deaths in a population, your answer would be positive, indicating an increase over time. If more individuals are dying than are born, the rate is negative. Other factors that can influence population size include immigration, or individuals moving into a geographic area, and emigration, individuals leaving. Note that this calculation does not include movement, nor indicate any reference to the gene pool. It's all interconnected, but that's another episode. Reproduction that is off the rails and without constraints results in the exponential growth of a population. To say grow exponentially, we mean increase quickly and by increasingly large amounts. If we were in AP calculus land, we would be calculating derivatives. But let's not go there. Think of bacteria in their Goldilocks zone, the perfect warm temperature and just the right amount of moisture. The back of your throat, perhaps. 1 bacteria becomes 2, 2 becomes 4, then 8, 16, yada, yada, yada. A few hours later, you are down for the count with strep throat. But this is an idealized example with a growth rate of 1, and it doesn't really occur in nature very long. Graphically, it would look like a J-shaped curve. To calculate the exponential growth of a population, you multiply the population size by R max, which is the maximum per capita growth rate of a population. This value might be given to you directly or interpreted from a data set. For example, if a population grows from 10 to 13 in a given time frame, then the growth rate is 0.3. If R is greater than 0, the population is going to have fast, exponential growth. If the ecosystem stays relatively stable, we can expect the growth rate to also stay the same, allowing for us to make population growth predictions. But upset the apple cart with other influencing factors, floods, famines, disease, invasive predator, and the R value will also change. We don't expect to see exponential growth in most circumstances or for extended periods of time. When a population produces a density of individuals that exceeds the system's resource availability, a logistic growth model will be applied. There just isn't enough to go around for everybody. The population cannot increase indefinitely, but will instead have a carrying capacity. Essentially, there is a limited amount of food, water, and shelter that a geographic area can supply. We begin our calculation the same way as exponential, with R max times n, but also now multiply that value by a parentheses k minus n over k. K is the carrying capacity, the maximum population for resources available. As your population increases, density increases, and you continually run up against limiting factors, which slow your growth. If you observe a population graph that is at carrying capacity, there will still be some small peaks and valleys, but the average population is consistent and seems to level off. Other factors can also influence population size, but are classified as density independent and include natural disasters like fires and floods. Essentially, the population size has changed due to chance and not overcrowding. To recap, births versus deaths. In the circle of life, every organism is trying to get their fair share. If resources and space allow, populations experience exponential growth. However, this is fleeting, followed by logistic growth as populations settle around the carrying capacity. Throw in a few natural disasters, and the population number is altered once again. Coming up next on the APsolute Recap Biology Edition, ecosystem disruptions. Today's question of the day is about species. What type of species, R or K selected, has less offspring and includes parental care? For the answer to today's and future questions, please follow us on Instagram at the APsolute Recap. That's the APsolute Recap. If you are a student with questions or a teacher with suggestions, we'd love to hear from you. If you have a biology topic or another AP subject you would like us to cover on the APsolute Recap, please email us at the APsoluteRecap@gmail.com. That's the APsolute Recap@gmail.com. The APsolute Recap is produced by Brad Kingett with music by Zach Caruso. Please remember to rate, review, and subscribe wherever you get podcasts. Time's up, pencils down. Thank you for listening to the APsolute Recap Biology Edition. AP is a registered trademark of the College Board. Copyright 2020, APsolute Recap, LLC, all rights reserved.